left off on?
No, I think we only had like 2 months left.
Yep. Because we are right here. Because we did 2 yesterday with. Okay. So, do we need to see another example of reflection across the x-axis or y-axis? Or do we feel comfortable with using the reflections? We feel good with reflection? Okay. So what we'll do is move on to the last type of transformation, which is horizontal stretch and shrink and vertical stretch and shrink. Yes. High school was from Hendersonville, in Hendersonville, Tennessee. So guys, so for horizontal stretch and shrink, the main general function that we'll be using to apply this here is y equals a f of a times x. Now the big thing is that whenever we do horizontal stretch or shrink, we have to flip the value that we have. So if the value that they give us is 2, the one that we're going to plug into the function is not going to be 2, but it's going to be 1/2. We have to flip it for horizontal stretch and shrink. Now for vertical stretch and shrink, the general function is a times f of x. So whatever the number is, we put it in front of the f of x, and then we will multiply it by the function. So the only real trick to horizontal stretch and shrink is remembering that we have to flip it. We've got to flip it from the value that they give us to 1 over that value. So let's look at the first one here. So the first one is we want to use this function here and rewrite it. Rewrite a function h whose graph is a vertical stretch of the graph of f by a factor of 2. So what we're saying is that we have h of x is equal to, since we're talking about a vertical stretch or shrink, it's going to be a times f of x. It's going to be a times f of x, where a is the value of the stretch or shrink. And in this case here, our stretch or shrink's value is going to be what? A number, which is? Because we're stretching this graph by a factor of 2. So we're going to put 2 in place of a. Now we'll replace the function f of x with what they gave us. So the absolute value of x minus 3 minus 5. Any questions on this here so far? Now all we need to do is distribute the 2. So multiply it by the absolute value and by the negative 5. Now we multiply 2 by the absolute value. We're really just putting 2 times x minus 3. We're not going to distribute or multiply the 2 into the absolute value. We'll just have it out front. Now the other part we have to do is 2 times negative 5. And 2 times negative 5 would give us negative 10. And that would be it there. Questions on this here? So this here is similar to what we did for kind of like our reflection across the x-axis, but instead of just applying the negative through the function, we're applying a number. We're multiplying a number through. That's the only real difference. Questions on this here? We'll be ready for the next one. All right, so you'll have to change this a little bit because I think yours says vertical. Yes? We need 1.3. So we want to I'm changing it back to horizontal instead of vertical because again, there will be two horizontal shrink or stretch on the homework. So we'll need to do this as a horizontal. Now, when we look at this as writing a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3, what we're saying is g of x is equal to f of a times x. Now the value that they gave us for this shrink is 1/3, but we're not going to plug 1/3 into it. We're going to flip it. So instead of 1/3, it's going to be what? 3/1, which is? We'd have 3 times x. Any questions over this so far? Now, this time we don't have f of x, we have f of 3x. So the x in the function is going to be replaced with 3x. So we'd have the absolute value of x minus 3, and we have minus 5. And again, at this point, we can go on and just drop the parentheses, telling us that g of x is equal to 3x minus 3 minus 5. That's it. Yeah, that's the answer. Any other questions on this one here? You ready for the next one? Write a function g whose graph is a horizontal stretch of f by a factor of 5. Yeah, so we'll want to change it back to horizontal because I think when I wrote those note sheets up, I forgot. Well, at one point I just had them all as vertical, but again, yep. I really looking back at these here, there's not a whole lot of difference or too much to these horizontal stretch or shrink. Because the only thing we really have to remember is that the number that we plug into the function is not going to be 5 for this one here. What is it going to be? 1/5. Because for horizontal, we have to flip it. That's the only real thing we need to remember. So we're writing a graph, g of x, guys. No, Brendan, take them off. Are they prescription?
Yes, they are.
Do you have a prescription for them?
Yes.
Then why were you not wearing it yesterday or the day before? Take them off. Guys, now when we look at this here, because we're talking about a horizontal stretch or shrink, in the general form, we're talking about f of a times x. F of a times x. And a is going to be the value of what we stretch or shrink this graph by. Now the value that they gave us was 5, but because it's horizontal, we have to flip it. So we have to flip it from 5 to 1/5. And that's the only one out of all the ones we've talked about today and yesterday that we have to do something to it. Because so far, we set up the one that for horizontal stretch or shrink, which is our f of a times x. Since the factor is 5, and again with horizontal, that's the only one we have to do something to. So we have to flip it to 1/5. Now we just need to plug this in for everywhere x appears in the function they gave us. So 1/5 x minus 1. And that's it. Yes, sir. Yes. No.
I'm gonna be completely honest with you. I haven't even got one. I wasn't there for whatever reason.
They're in the office.
They're in the office. Okay, I didn't know where they was at.
Yep.
Okay. You always be like me.
Any other questions on these here, on this one here? Let's look at the next one here. So this one here, we want to write a function h whose graph is a vertical shrink of the graph of f by a factor of 0.25. Now, since we're talking about vertical stretch or shrink, our general form of this is a times f of x. A times f of x. Now, since it's vertical, we don't have to do anything to the value of a. We can just plug it in its spot. So, a is going to be what? Well, what's our scale? What number did they give us? So a is going to be 0.25. So we put that in place of a. Now we can plug the function in place of f of x, which is going to be our absolute value of x minus 1 plus 2. Now we do have to multiply through by the 0.25 to get our final answer.
Yeah.
So we're going to first multiply it by the absolute value. Now again, we're not going to multiply it inside the absolute value bar. 0.25 times the absolute value of x minus 1 plus, we have to do 0.25 times 2. So that would be 0. What?
Oh, yeah,
25 times 2. Mm-hmm. Yes, sir.
Okay, is that 1x minus 1, or is that one of those bars?
That's one of the absolute value bars.
Oh, okay.
You're good.
I started wrapping my fancy ones to keep from getting that mixed in.
Yep. Either one of those will work. Any other questions on this here? Not going to have something else going on tonight, unfortunately.
It's just as long as we get to the real games, we'll be okay.
I will be able to make those. Any other questions on this here? Because I think this is the last one we have for vertical stretch and shrink. So if we look at this one here, we want to rewrite a function g of x, or write a function g of x. That is a vertical shrink of this function by a factor of 1/3. If it was horizontal. So vertical stays the same. In our vertical stretch, the general form is a times f of x, where a is minus 3. Yep. Let's stop, Logan. Thank you. Now, guys, we need to multiply through by the 1/3. We need to multiply each one of these by 1/3, and then when we multiply the absolute value of x by the 1/3, we get 1/3 times the absolute value of x. Now the next one we need to do is 1/3 times 3. It's just going to be 1. Because 1/3 times 3, Brendan, thank you. And this right here will be the answer.
So really all you're doing is put that over there.
And then multiplying through.
Yeah.
Any other questions on this here? These are going to, this one and the one after it are the last two problems we're going to look at today. Now, the only thing that's different from this one than what we've been doing is that we're going to be doing more than one transformation. And when we look at these here, we're always going to go in the order in which they appear. So let graph G be a vertical shrink by a factor of 0.25, followed by a translation 3 units up of this graph. So we're going to go one at a time. We're going to do each one as they appear. So the first one that they gave us was a vertical shrink by a factor of 0.25. Now the finishing function will be in the form of g of x, yes? So we need one in between because we're not going straight to g of x. So we'll pick, say, h of x for the first one that we're applying the vertical shrink to. Because once we apply that vertical shrink, then we're going to move it up 3. So we're doing 2 movements here. So for the first one, vertical shrink, we talk about a vertical shrink, we're talking about a times f of x, the ones that we just did. Now for us here, our value of a is 0.25. So we'll put 0.25 in place of a. And for us here, f of x is what?
3.
So our f of x function, f of x equals, and when we multiply these together, we get 0.25 x. Any questions on this one so far? So we've finished the first part. We've applied the first transformation. Now we need to apply the other transformation, the last one, which is a vertical translation. We're moving it up or down. And the general form for moving up and down is going to be our f of x plus k. Well, we're not applying it to f of x, we're applying it to what? H of x, because that's the function we're applying it to. You're good. Now in this case, the value of k is 3. Now would it be positive or negative? Because it's going up. Now h of x in our case is what?
so you just kind of add that to it.
And we can put parentheses around it because we're adding it in. Yep.
I think hates you sometimes.
Yes. But that is the final function. Because when we do these combinations,
Because there's nothing outside it.
yes. Now, whenever we do these, even if there's more than two, we always go in the order in which they list them. The function, whatever transformation they list first, we'll do it first, followed by the next one, then the next one, going down the list. So even though we're adding more of them to it, it's still the same thing we're doing. We're just taking them one at a time. Any questions on this here? Question?
No, I was just.
You know what?
Flies only live 7 days.
Probably depends on the species.
There's different types of flies. Yeah. No wonder the coat fly.
If I remember the species, there's the, I think African willow fly only lives 28 hours.
28 hours a day.
There's many types of different flies.
Dude, your wife told me you're a dang fly hunter.
All right, guys, let's finish this one up here. So again, we're doing two different transformations on this one here. The first one, we want to let the graph of G be a translation 6 units down, followed by a reflection in the x-axis. So the first one we'll do is the translation of 6 units down of the function f of x. So we'll have f of x plus k, where k is our transformation, which in this case is going to be minus 6. And we're saying minus 6 because it's going 6 units down. And since the f of x is the absolute value of x, we will replace it. And this is actually our function, the absolute value of x minus 6. Because we can add the parentheses in, but then we would just drop them. So that is for the translation of 6 units down. But we also have a reflection in the x-axis. Now, to get to our function g of x, well, the reflection in the x-axis is our negative, or well, in our case, it's not f of x, it is negative h of x. Because f of x was our original function, the absolute value of x, but we don't have that anymore. We've translated it 6 units down, which is now our h of x, what we call h of x. So really, we have negative, parenthesis, absolute value of x minus.
That's all.
Now we can apply the negative to both of them.
Negative x something, that thing hates you.
Yep.
There you go, you got it.
So when we apply the negative to the absolute value of x, we'll have negative absolute value of x. The negative and negative 6.
Ciao.
And that's it.
Cool beans.
Questions on this here? And that is it. So this here is your homework assignment for 1.3.